Hello everyone. On this cycle, I'm just going to talk briefly about different use cases of ICMP and how ICMP can be used to circumvent firewalls and IPSs and IDSs. So ICMP stands for Internet Control Message Protocol, and hopefully most of you know this one. And it works at layer 3, so it works at the same layer where IP works. So any system where there's IP protocol stack installed, usually you have ICMP in there by default. ICMP has two main operations: reporting using the ICMP error messages, and the famous ICMP echo and echo reply, or different types of query messages related to ICMP. The difference between ICMP and other TCP/IP protocols that it does not have any service ports. So it's pretty much what it uses is these types and codes. So each ICMP type has a different code number with it. That's usually encoded into the packet's header. If you want to learn more about the different codes and different types, there's a link from the IANA.org where you can take a look at that. So ICMP can be used for a lot of good things and bad things. So ICMP in any network, you will find some ICMP traffic permitted somehow. Usually ICMP is overlooked. So a lot of security practices, they will just omit ICMP. They will say, okay, let's just make sure that no one can ping from outside to the inside of the corporate, but no one will look further. So some conventional uses of ICMP, the famous and mother of all network tools, the ping. It's pretty much used to validate network reachability to hosts. It's pretty much you send some packets to the other end, and the other end would respond back with some responses and time to live and retry times and so on. So it's pretty much useful. I think Bing, very useful tool. Another use of ICMP, such as path MTU discovery. If you want to set up systems and you want them to talk, and you want to make sure that MTU and MSS size on this link is proper, so you want to make sure that packets can go through without fragmentation or anything. Router discovery, that's been used recently with IPv6, for example, using the router solicitation. So it can discover neighbors. Router can talk to the neighbors using ICMP messages. And also ICMP source cache messages. And this plays a role in network congestion control. So there's a lot of uses for ICMP, and definitely a lot of good things you can use it to in your network. But at the same time, there's a lot of non-conventional uses of ICMP, and that's the main topic of this presentation. One of the major use cases of ICMP, which usually all the time is overlooked, especially this one, which is using tunnels of ICMP, creating covert channels. So pretty much ICMP would be permitted somewhere on the organization. And if an attacker was able to find that little spot, he can use ICMP to transfer files, to do remote command execution, and usually you can tunnel anything inside an ICMP payload. You can do TCP/IP, you can do a TCP, UDP, any type of payload you can definitely encode into an ICMP packet. Other functions also kind of uses of ICMP for reconnaissance. You can use ICMP with traceroute to figure out network map. You can use it with the different error messages to be able to tell where the edge of the network is, how many routers on the path, and so on. And it can also be used for denial of services. The old one, which is Bing of death, can be used for resource exhaustion. Pretty much you can do a lot of bings at the same time, and you can take machines down, and that will definitely affect availability. So the covert channel is pretty much like any other tunnel. You have 2 points and you establish a tunnel, but this tunnel will use ICMP echo request and echo reply messages. The tunnel can be used to bypass any type of security you're looking for, firewalls, IDSs, IPSs, and so on. Because usually, as I said before, it's overlooked and people don't look deeply into what's inside an ICMP. They expect it a regular payload and they just take it like that for granted. So with an ICMP packet, there's a payload field. You can put whatever in there. You can get going. So you can use it for remote command line access. You can use it to transfer files, which both of them I've done before. So here we go. I'm just showing two examples of how you can add payload to an ICMP packet. First of all, just using the bin command, so everyone has this on the computer. If you happen to have an access to a Linux machine, then HBing2 can do that for you more efficiently. So here I'm just showing how you can add packets to an ICMP packet. Add, I mean payload, sorry. So the different tunneling tools, you can write your own script, or probably something like a client and server, Python, Perl, anything, and you can use that to tunnel the traffic. The one I've tested is this old one called Luki, which is part of the Kali and Backtrack Linux. But nowadays, what I found out, there's a signature for Luki traffic, and IDSs can detect it without any hesitations. There is ptunnel from MIT. That's also a very good little tool you can try if you want to. Other tools I've just listed here, there's Uncovered and 007 Shell and CMBTX. All these little tools, their main job is to establish a covert channel. It's pretty much a channel between two endpoints, and these tunnels will be using ICMP as a carrier. Mitigations, you can permit only fixed size ICMP, so you can definitely look at your IPS and say, or even firewall and say, okay, all my ICMP traffic should be 64 bytes or should be 17 bytes, whatever size you think they need to be, and you just have to make them like that, or 20 bytes. Some IDSs already have signatures, as I said before. For example, for this Luki, IDSs are able to detect it because they just know exactly how it works. So with all that being said, I can say the only real mitigation would be to block all ICMP traffic and just leave alone. But I don't see this as a practical solution, as you need ICMP within your network to do testing, troubleshooting, and many, many other things. And also, I would say if you write your own scripts, it's really very, very difficult to get detected. You can get fancy with the script. You can make the packets look different every time you send them. You can craft them to be exactly like regular bings, which usually allowed through firewalls. And so some resources I've listed here, I didn't have a chance to actually do any proof of concept or anything, but I have done this before many, many times, and it's definitely a success.